When a force of 120 Newton is applied to a certain spring, it causes a stretch of 2.25 centimeters. What is the potential energy of this spring when it is compressed by 3.5 centimeters or expanded by 7 centimeters? Springs are very important elements in modern technology. They are found in machines of all kinds like in watches, toys, cars, and trains. Work done by an applied force in stretching or compressing a spring can be recovered by removing the applied force. Like gravity, yung spring force ay conservative force then as long as losses through internal friction of the spring can be neglected. And that means that itong spring can also provide a potential energy function. In this figure, makakita tayo ng isang spring na nasa equilibrium position or unstretched. Dun sa pangalawang figure, we have a stretched spring, and dun sa panghuling figure, we have a compressed spring. In our figure, at letter B and letter C, if we pull the string or push the string, as we can see in the figure, the spring stretches or compresses a distance x. Usually, ginagamit natin yung x as a coordinate. Para sa spring, nire-represent nito yung displacement from the equilibrium position. Makikita natin sa letter A na 0 yung value ng x kasi nasa equilibrium position pa yung spring. Kapag hinila natin siya to the right, ito yung value ng x, and kapag pinush naman natin siya to the left, this is the value of the x. If we can notice experimentally, it turns out that doubling a given displacement requires twice the force and tripling it takes 3 times the force. Mas hahabaan mo yung distance nung value ng x, mas magiging malaki yung force na kailangan mong i-apply, pahila or patulak. This means that the force exerted by the spring, yung Fs na nakikita natin dito, yan yung tinatawag natin na spring force or yung restoring force. This means that yung force exerted by the spring, yung F sub S na yan must be proportional to the displacement. That's why we have the formula for the spring force, K times X, where yung K natin is a constant of proportionality, the spring constant carrying units of Newton per meter. This equation here is called the Hooke's law after Sir Robert Hooke, who discovered the relationship. The spring force is often called a restoring force because the spring always exerts a force in a direction opposite the displacement of its end. Laging kinokontra nung force na yun yung force na ini-apply natin dun sa spring, patulak or pahila. And it tends to restore whatever is attached to the spring to its original position. For positive values of x, the force is negative, pointing back towards equilibrium at x is equal to 0. And for negative x naman, the force is positive, again, pointing towards dun sa x equals 0 natin, dun sa equilibrium position. For a flexible spring, yung value ng K natin is a small number around 100 Newton per meter. Whereas kapag stiff spring naman, malaki yung value ng K natin around 10,000 Newton per meter. Yung value ng spring constant K is determined by how the spring was formed dun sa kanyang material composition and the thickness of the wire. Yung force na i-apply natin sa spring varies linearly from 0 at the unstretched position to where stretched to the x. Say for example, kung isosolve natin yung average force is equal to from 0 hanggang dun sa spring force na maabot natin or yung kx over 2. Simply, yung average force natin is equal to kx over 2 na lang kasi nag-start siya from 0 and ang average ang pinag-uusapan natin. If we are going to solve naman for the work na ipinoprovide natin gamit yung spring, say work applied, this is equal to the force average. Again, force average ang ilalagay natin kasi the force varies linearly. And i-multiply natin dito sa x, since yung x ang nag-represent ng distance ng compress and stretch ng spring. So if we're going to substitute this value here, work applied is equal to kx over 2 times the x. Madederive natin yung formula for the elastic potential energy. So, elastic potential energy is equal to 1/2 kx squared, where yung k again is the constant of proportionality. Yung x is the distance ng pagkaka-stretch or pagkaka-compress ng spring. Example number 1, find the potential energy of a spring with force constant K, 740 Newton per meter if it is stretched by 2.1 centimeters. For example, this is a spring, and ito yung kanyang original position na stretch siya hanggang dito. So this is the X. Ang value ng X natin is 2.1 centimeters. And ang applied force of course is to the right. We are asked to find the potential energy na ipinoprovide nung spring. To solve for that, elastic potential energy is equal to 1/2 kx square, and we just have to substitute the value since alam naman na natin yung x and alam na natin yung k. 1/2 times k, ang k natin is 740 Newton per meter times the x. So yung 2.1 centimeters, we have to convert it into meters para mag-fit yung units natin. So we have 0.021 meters quantity square. By calculating, the elastic potential energy is equal to 0.16 joules. Since the potential energy depends on the x square or dun sa kanyang stretch and compressed distance, which is positive even if x is negative, the potential energy of a spring is always greater than or equal to 0, never magiging negative. Thus, a spring's potential energy increases whenever it is displaced from equilibrium. So this is example number 1. Example number 2. Find the force constant of a spring whose potential energy is 1.7 joules when it is compressed by 6.4 centimeters. In this problem, ang hinahanap naman sa atin is yung value ng K. Again, using the equation, elastic potential energy is equal to 1/2 K times x square. Given sa atin yung potential energy, we have 1.7 joules and yung compression distance niya, we have 6.4 centimeters. By just substituting the values and by deriving the equation, masasolve na agad natin yung value ng K, yung force constant. We cross multiply this one, so this is 2 times elastic potential energy. This is equal to k x square, and dividing both sides by x square para matira yung k. K now is equal to 2 times potential energy elastic over x square. Substitute na natin yung values. 2 times ang potential energy na given sa atin is 1.7 joules. Divided by ang x natin is 6.4 centimeters. In meters, ito ay 0.064 meters. Kaya lang, we have to be clear that yung spring natin ay compressed. So, itutulak siyang pa ganyan. For example, ito na yung kanyang pagkakakompress. Ito yung equilibrium position niya. Yung x natin is negative 6.4 centimeters. Assuming this is the positive sides. But again, kagaya ng nabanggit natin sa previous example na since naka-square lagi yung x natin, bali wala na yung kanyang sign. Kahit negative ito, this is square. K natin is 830 Newton per meter. So this is the value of K. If we can notice that yung potential energy for the gravity and yung potential energy for a spring are given by different expressions. And gaya na banggit natin, each conservative force has its own form of potential energy. This is example number 2. When a force of 120 Newton is applied to a certain spring, it causes a stretch of 2.25 centimeters. What is the potential energy of this spring when it is compressed by 3.5 centimeters or expanded by 7 centimeters? In our figure, sa taas, makikita natin yung stretch distance sa 2.25 centimeters kapag in-apply siya ng 120 Newton na force. Sa lower figure naman natin, makikita natin that yung same spring compressed by second force, say F2, makita natin, which causes a compression of 3.5 centimeters. An expansion of the spring by 7 centimeters would look similar dun sa top sketch kasi papahila din siya. From our problem and from this figure, a certain force causes a certain stretch. We can calculate the force constant using yung equation natin na F equals K times X kasi wala namang given sa atin na force constant. So we have to solve it pa para mahanap natin yung potential energy na kailangan natin kapag na-compress siya by 3.5 centimeters or pag na-stretch siya by 7 centimeters. And again, to solve for the potential energy, gagamitin lang natin yung equation na 1/2 kx square. Let's solve first for the force constant. F is equal to, ang gagamitin natin is yung unang given. We have 120 Newton and yung stretch distance sa 2.25 centimeters. Solving for K, we divide both sides by dx. K is equal to, ang force natin is 120 Newton over dx na 0.0225 meters. And by calculating, ang K natin is equal to 5,333.33 Newton per meter. Again, kung ano yung K na na-solve natin dito, siya na yung gagamitin natin to solve for the potential energy kapag na-compress yung spring ng 3.5 and kapag na-stretch ng 7 meters. Hindi natin pwedeng gamitin yung K na to sa ibang spring dahil iba na yung material composition ng spring na yun. To solve for the potential energies, kapag na-compress siya ng 3.5 centimeters, assuming this is the positive sides, again, yung signs na yan, hindi siya magmamatter kasi i-square din naman natin yung x. Again, nabanggit natin kanina that yung potential energy at elastic is positive always. At x equals 3.5 centimeters, potential energy natin is equal to 1/2 kx square, and by substituting the values, 1/2, ang K natin na gagamitin is yung 5,333.33 Newton per meter times ang X natin is negative 0.035 meters quantity square. Elastic potential energy at the scenario na kinompress natin by 3.5 centimeters is equal to 3.27 joules. At this stretch naman, 7 centimeters. So this is positive na. Ito kanina is negative. Elastic potential energy is equal to, again, 1/2 kx square. Substituting the values, elastic potential energy is equal to 1/2. Ang K natin is the same, 5,333.33 Newton per meter times the X na 0.07 meters quantity square. By calculating, the elastic potential energy here is equal to 13.07 joules. In this type of problem, in case hindi natin alam yung value ng force constant or yung variable na K natin, we have to find first the value of the K para may apply natin siya to solve for the other potential energies required. We just have to make sure na meron tayong given na force and some distance in terms of dx. So this is example number 3.